In this lecture, I am going to introduce you to integration solutions. So firstly, what is an integration? Linking different applications is nothing but integration. We already know how to write mule flows. We know that mule flows contain integration logic or orchestration logic, which will orchestrate with different components or applications. So I can say that my mule flows contain integration logic. So actually, let's assume that I have a scenario for integration. That means I have an integration problem. And as an architect, I need to propose a solution. What all things to consider while proposing a solution for an integration problem? That is what is nothing but integration solutions, right? So in any application, there will be stakeholders. Whatever solutions we are going to propose, that should satisfy all the stakeholders involved in this project. Hey, what do I mean by stakeholders? So examples are business users. The final end consumers of the solution are nothing but one of the stakeholders. So definitely whatever solution we are proposing, that should be satisfying this business users. Another stakeholder is our analysts or managers. These managers or analysts are responsible for managing the scope of the project, the business value, cost, resource usage, etc. Right? So solution whatever we are proposing should satisfy these stakeholders also. Other stakeholders are like database administrators and network administrators. These are also stakeholders because they manage the database or network, right? And developers, of course, are also part of this application, so they are also a stakeholder. And very importantly, auditors who verify the compliances, policies and integrity of the company are another major stakeholders. So our solution should satisfy these auditors as well. Other stakeholders are like system integrators, who are responsible for external systems that our application will interact with. And of course, another stakeholder is architect. That means you, who are responsible for designing the solution. So these are all the various stakeholders, right? As an architect, I need to communicate with various stakeholders and get the requirements from them. The most important objective of integration solution architecture is to address the in-scope requirements of stakeholders related to the integration scenarios. So as an architect, I have to document different views to address the goals and concerns of various stakeholders. We have to carefully document and balance the requirements of various stakeholders and their viewpoints, right? So while giving an integration solution as an architect, we have to consider the following. How reliable is my solution? So let me take an example. Let's assume I have a scenario where I need to read from a file and process the records in the file and then write to database. So let's assume that I have a CSV file with say 10,000 records. Now let's assume that I develop or I propose a solution like this. In my flow, I will have a component which will poll for the file and get the file. In Mule we have on new or update file, right? So I can poll, get the file. Then after that I can write transformer to transform the data into whatever format I want. And now what I want is for each element, I want to execute some logic using some component and finally insert it into database, right? So what I did is I used a for each scope, let's assume, iterating through each of the element and then inserting. Now, is this a reliable solution? What do I mean by reliability? Suppose if 10,000 records are read and transformed, okay, all the 10,000 records, now my for each is getting it as a stream, okay. So for each is iterating over the stream and inserting. What will happen after inserting 500 records? What will happen if the connection to database is lost? Or suppose my mule application crashed due to some reasons. What will happen? Only 500 records will be there in database. The file, let's assume that it gets deleted. The file got deleted and only 500 records got inserted. I lost remaining records. So this solution is not reliable, right? So when proposing a solution, I need to give a reliable solution. Reliability aspires to have zero message or data loss after a mule application stops or crashes, right? And also I need to consider durability. How durable is my solution? Durability, what do I mean by durability? It is the ability of a product to remain functional when faced with challenges of normal operation. So suppose if I propose a solution to run my mule application on only one mule server, what will happen if my mule server crashes? My application will have a downtime, is it? So maybe this is not a good solution. According to my SLAs, I don't want downtime. I want zero downtime. So the good solution is to propose to have a cluster of instances behind a load balancer maybe, right? So again, so whenever I'm proposing a solution, I have to consider this also, right? And we have to consider the performance also. Like take an example here, in the earlier solution whatever I proposed, I am iterating over for each and then writing to database. So here we are doing synchronous processing. Maybe if I can design or modify my solution so that the records can be processed parallelly or concurrently, it will be good, right? And also instead of writing each record to database, it will be good if I can aggregate up to 50 records and then do one bulk insert for 50 records at once. Yes. So there are a lot of things to refactor. So while proposing a solution, I need to consider the performance and also security. I need to consider the security. Let's assume that I have my application deployed on Cloud Hub, and this Cloud Hub is talking to a database on premise, and the data on-prem, right? And the data, this is a database on-prem, and the data in my database is very secure. It is a confidential data. If the data is transferring from Cloud Hub to database on premise over the internet, public internet, the data might be compromised. So how to secure the data transfer? Maybe I need to configure a VPN between the VPC of Cloud Hub and my corporate network. I need to configure a VPN for between this VPC and my corporate network, right? That is one thing. Or let's assume that I am exposing my APIs. In my application is exposing an API and I want to expose that API over HTTPS. HTTPS means I should be able to configure a certificate. How to configure the certificate? So maybe my organization requires a dedicated load balancer instead of using a shared load balancer provided by Cloud Hub. How to configure? These are all the security considerations which I need to consider. And also how to implement the best testing strategies. Most important in any application is testing. We have to develop best testing strategies to test our scenarios, right? And then next one is logging. if there is any problem, we should be able to identify the cause for the problem if I have logs. So how to design a logging system? Do I need to integrate with third-party logging systems like Splunk or other third parties, etc.? I need to give a solution. And also, we should be continuously monitoring my application's performance, right? What are all the various monitoring tools available? What all are the various metrics we can monitor? So we have to propose a solution for that as well. And also transaction management to make sure that we achieve ACID properties, atomicity, consistency, and isolation and durability of my data. So we have to consider a lot of other factors also, right? Okay. And also while designing integration solutions, we have to consider both functional as well as non-functional requirements also. Mostly functional requirements are often discovered from user stories. So if I have user stories, I'll understand the functional requirements. But non-functional requirements are beyond or outside of user story. What are the examples of non-functional requirements? Example might be a system must survive mule runtime restarts. This is one non-functional requirement. And the data at rest must be encrypted as per corporate standards. This is another non-functional requirements. So my solution should consider both functional and non-functional requirements. So one more important thing is, whenever I'm designing architecture, I need to document various views of various stakeholders. So for a same problem, there can be multiple views from different stakeholders. I need to document those views. I need to design a solution for all those various views of the same problem. So there are multiple ways. MuleSoft recommends to use 4+1 view architecture. So what are these 4+1 views? That is a logical view of your solution, process view, development view, physical view, and +1 solution is scenarios. We'll discuss about all these views. What do they mean actually? I'll put it very simple. Okay. So let's take a software. Any software has different stakeholders. Every stakeholder will view in a different way, right? So suppose if I take a Linux operating system as a software, my Linux operating system logical view will look like this. A Linux operating system has a memory manager, process scheduler, file system, network interface, and IPC, enterprise communication. These are all the various modules of Linux. So as a Linux administrator, if I see at a high level, I will see, hey, what are all the functionalities provided by Linux operating system? These are all the various functionalities. So a logical view tells us a high level functionalities without going into low level details. What all features are provided for the end user. If it comes to our Mule application, I can say, let's assume that this is my Mule application deployed on a Mule runtime. If I am exposing my application as an API to the end users, right? What does the end user see? Do you think the end user will see how this API is implemented? No. For them, my API documentation, like suppose if I write a RAML file, right? RAML file will describe my API like /products will give you all the products. Get request to /products. Post request to /products. Get request to /products /name. So like that, my API design is nothing but a logical view to the end user. So he sees what all features are provided by my application. For him, API is a logical view, right? What all it provides. So don't worry, different blogs or different articles will show this logical view in multiple ways. So I am showing you various scenarios, various ways. So for a mule application, I can say that logical view is nothing but my API which tells what all features. Or if we consider my application as multiple APIs, if my application is comprised of multiple applications which are exposing APIs, I can say definitely will be having system layer, process layer and experience layer, right? I can say for my application level, when I see at an application level, not at a particular API level, right? At a whole, if I see, I can say that these are all the subsystems of my bigger application, bigger functionality. So I can say that these all are providing me a logical view, each component or each application, right? It is a logical view. So it depends, right? Many blogs will say it in different way. Okay. Now, once you understood about logical view, this is a logical view of a Linux OS. But again, inside this, there is a subsystem called as file system, right? If I again go inside that, these are all the, again, this is a logical view again for a particular component. It contains all this. Okay. Now, if I go into deeper again, I can see these are all the various components of a Linux operating system and they interact with each other in this way. A memory manager will interact with file system to load the file. A file system may interact with network interface to load a file from a network, right? So if I actually show you this process interaction between various components, this is a process viewer understanding how various processes are communicating with each other in an operating system, right? But if I see in terms of a mule application, can I say like this? This is my flow and my flow is containing the logic on how it should interact with the other third-party systems and databases or message brokers, etc. So my flow is containing the interaction logic, right? Can I say that my flow is giving a view of a particular application at a low level? How multiple processes are communicating with each other? Yes, I would say that flows in my application, not one single flow, flows in my application and their interactions with other third-party systems or databases, etc. will give me the process view of the application. So as an architect, while designing the process view, I need to consider a lot of things, right? So this gives me a picture. A process view should be documented and we should actually document the details of concurrency. So take an example. If I am designing a process view for the earlier scenario, what was that? Yeah, this one. If I am designing a process view, if I am documenting the process view of this problem, what is the problem? Read the record from a CSV file, transform it, and each record I should do some logic and then insert to database. If this is a one, I also need to document how to concurrently process the records, right? And how to reliably process the records, right? And also if I design a solution like this, how scalable it is, how many instances I need, whether I need to do vertical scaling or horizontal scaling, right? How is the performance? I need to document the information about all these things when I'm documenting a process view. And when it comes to the next view, that is a physical view. Physical view is very simple. Actually, we have multiple runtimes. CloudHub is a runtime, standalone runtime, and we have other things called as Runtime Fabric and Private Cloud Edition. So don't worry about all this Runtime Fabric and Private Cloud Edition I'm going to discuss in detail in specific modules. So when I actually designed a solution for my application, do I need to deploy it on Cloud Hub or standalone runtime or Runtime Fabric or Private Cloud Edition? According to the SLAs or policies of my organization, which will be effective, cost effective, right, as well as effective in other ways of performance. Where should my deployment be done? This also should be documented inside something called as physical view, or we sometimes call it as deployment view, right? Okay, the next one which I want to discuss is development view. We discussed about all this: logical view, process view, physical view or deployment view. Now development view. Actually, when designing or when documenting a process view, I'll document about concurrency, performance, everything, but I will not document what component of Mule is more appropriate for a particular scenario. I'll not document that. I will be documenting in development view. What all MuleSoft provided tools can be used to develop a particular scenario or a particular flow, that I need to document in a development view. That will help a developer to understand what components to use effectively, etc. Right? So how to configure for a developer? From a developer perspective, I have to actually document what all things to be used, how we should configure, etc. Right? That is a development view. And the last one is scenarios. Scenarios are nothing but use cases. The use case view of the solution, right? These are all the 4+1 views. So as an architect, whenever I am proposing a solution for an integration problem, I need to document various views of stakeholders like this. 4+1 view is sufficient to consider and to satisfy various stakeholders. Once I design and document my solution, I should get the approval from my various stakeholders, and once that is approved, then this is a final design document, right? So in the next video, I am going to tell you the agenda of this course, where I'll tell what all are provided by Mule, what are all the options provided by MuleSoft for designing a process view efficiently, like concurrency, performance, monitoring, etc. What all are provided by MuleSoft for various deployment topologies, right? We'll discuss about various things provided by MuleSoft and how to document each view. I'll give you an agenda in my next video, what we'll be covering for helping an architect to document all these views. Okay, see you in next video.